I'm going to go to our section title real quick and come back. Okay, 1.1, key features of a function. Okay, so again, domain is the set of all x values that give us real solutions to a function. Solution is a zero. It's also known as a zero or an x-intercept where it crosses the x-axis. All the same thing. Solution, x-intercept, zeros, solution, all that means the same. Range is the set of all y values that a function produces. You put in a domain and you get out a range. You put in an x, you get out a y. When you hear the word domain, you should be thinking x. When you hear the word range, you should be thinking what? Y.
For like it says what is the domain and range of the function defined. Do you want us to write that whole thing, or can we just write y equals x squared minus?
That's up to you. I would just put example, like ex, and then write the equation, and then we'll put domain and range under it. Okay, now it says, what is the domain and range of the function defined by y equals x squared minus 3? Okay, x squared minus 3 is a parabola. And at the very end of Algebra 1, you probably saw this shape. This is a parabola. This specific parabola would look like this. Please, helpful comments only. Okay. Now, this is the specific parabola. Is there any, domain is what I can put into a function. Is there any limitations to what I can put into x squared minus 3? No. Because like a fraction, we couldn't divide by 0, right? If there was a fraction in there. A square root, it couldn't be a negative number because I can't take a square root of a negative number yet. You'll learn how to do that, but it wouldn't be real. There's no limitations to this, is there? So the domain is all real numbers. So I'm going to write D for, guess what? Domain. I'm not going to write domain. You might want to write domain all the way out because this is, you didn't write the problem, right? Is all real. This is going to be my problem here. Numbers. But we are going to be writing these in different kinds of notations. Okay? We're not going to write the words all real numbers. I forgot my S. We're not going to write those words. We're going to have set notation and interval notation, and we're going to use those. So set notation, actually, just a second, I might be jumping. Just a second, we're not on there yet. Okay, we're not there yet. Okay, so that's their picture. I like mine better than theirs, don't you?
What is that?
Okay, no, you don't have to. You don't have to draw. Well, you could sketch it real quick. It's not that big a deal. It goes through -3, right? Okay. The shape is a parabola. Now, how did I know that this, I should have put -3 down here. How do I know this y-intercept is -3?
Because the line goes through.
Right, it goes through there, but how do I know here that's -3? Because on a y-intercept, what's the x value? 0, isn't it? Mm-hmm. So if I plug in 0 here, what do I get? -3. Okay? Every single y value, every single y-intercept right here, wouldn't the x be 0 every single time? Yep. So I can find a y-intercept by plugging 0 in for x. And that tells me that. And then it's positive, and you'll learn all this. We'll do all this stuff, okay? But now, what's the range? What's going to come out of it? Are all real numbers going to come out of it? Nope, look at the picture. What comes out of it? Yes, the range comes out of it. What kind of numbers come out of it, guys?
Negative and positive.
Okay, it starts at -3 and it goes what? Up. Does negative 5, is negative 5 in the range?
No.
No. Why not?
Everything's above negative 3.
Because everything above negative 3. So it's y is greater than what? Than negative 3. Is it can it be equal to negative 3?
Yes.
Yes. So it can be equal to negative 3 or larger. And we're I'm going to show you how to write these things in a minute. But the reason I know it's equal to is there a hole down there at negative 3? No. If there was a hole there, then it couldn't be equal to negative 3. It would just be greater than negative 3. A hole. We can have holes in graphs. You'll learn when you learned a graph on a number line, right? You had included and not included. Open and closed hole.
An actual hole.
No. You'll have open and closed points, just like when you did a number line in inequalities. So on the next slide, we're going to learn how to write these things other than words. And like I said, you are not going to understand domain the first time I throw it at you.
I will.
It's going to take some time
Well, why are you throwing it at me?
because I have to keep throwing it at you.
Why don't you just
Okay, so set builder notation. Set builder notation is usually just called set notation. Okay, set builder notation usually just called what?
Set notation.
Set notation.
Can I just put set notation?
Yeah, you can. The book will call it set builder. Just know that I probably will never call it builder, set builder.
It just sounds weird. I don't know.
It does. Okay, uses a variable description.
This is verbal.
Oh, yes.
No, it's a variable column.
Okay, or an inequality to describe a number. So we're using inequalities. Less than, greater than equal to, not equal to. So the last one, we just had all real numbers, correct? Okay. So the domain would be, you got these nice brackets. Watch how I do it. Down and then up. X. This line means such that. It's just a straight line. X such that. X was the set of all real numbers. And just a second, it's like, I don't know what it's
to
doing.
write the second one too.
Not till we're there, because you should be writing what I'm writing right now.
Double line R.
A double-lined R means all real numbers. Okay? So, this reads, this is a sentence. X such that X is in the set of all real numbers.
What's in the middle?
Okay?
This one?
That's a such that. That means such that. It's a straight line. Okay? Anytime you see that in a mathematical sentence, it means such that. And if I could write a little finer, I would write that. Write a little arrow so you know that that line means such that. Okay?
S? What is that?
It's a double-backed R.
Huh?
Okay.
No, the thing things after.
It's a curly bracket. Watch how I write it up here.
Oh, I know. Oh, that's horrible. That's
Well,
worse
this
than
pen, I'm learning how to use the pen. Okay. It needs to be a curly bracket. Now, the range, what was the range on the last slide? What was the range, guys?
Y.
Why?
Equal to negative 30.
Okay, so we're going to put y such that, so our curly brackets again. Why does that keep popping up? Okay, curly bracket, y, bless you, such that y is greater than, equal to, negative 3.
Carl, can you not throw stuff at me, please?
Got no
Control.
color bracket again.
Just throwing stuff.
Why aren't you writing what I'm writing? No, you're
I know
not.
that.
Not if you're, I don't care if you know it or not, please write it. And I would, really, you can, unless you want to pick up everything off my floor, stop.
It didn't touch the floor, Miss Mick.
Okay, stop. Okay, interval notation is a little bit different. Interval notation, we write it as an interval, like 6 to 20. Okay? I personally like set notation because we do a lot of things with intervals in here. And so I like to keep my domain and range separate from all my interval analysis that we do. The other thing is set notation is much cleaner to write. Interval notation can get really long and involved. Okay, so how we do this is, first of all, I'm going to put some things over here. Square brackets
Messages in the office.
means included.
Alex Seaman, Austin Forney, Tyler Johnson,
In
Dana
parentheses,
Seaman, Austin
guess what
Watts,
parentheses mean?
Simon Poole,
If brackets are included, not included.
Chance Swearingen,
Praise the Lord.
Eva Lee Harris, Sarah Johnson,
Okay. And it says you pick the minimum and the maximum.
Macy Thompson,
Okay? And that's what goes on the
Tyler
ends.
Kernan,
So if we're going to do all real numbers, what's the minimum?
Student Council, you have concessions tomorrow evening.
Isn't that like negative
There's volleyball
infinity?
games.
Yeah.
Okay,
Student council
what would be the
members
maximum?
to discuss.
It'd be positive.
Positive infinity. Can I ever get to negative infinity?
Shifts for
No.
working
Can I ever get to
include
positive infinity?
6 to 7,
No.
7 to
So, domain
if you are a player or have practice, you still need to go
would
in
be
and talk to Mr.
parenthesis,
Finney.
negative
Make sure
infinity,
you do not have an absence count against you.
comma,
You may sign up during IAP or
Positive.
after school. Mr. Finney will be there
infinity.
later this afternoon and
Parenthesis.
he'll be in his room.
That means all real numbers. Means everything.
Oh, and girls need
Got
to
it?
take the impact
Make sense?
testing during
Okay.
IAP with
Now,
7th grade
range.
boys. That'd be Kerrigan
What was the
Henry,
smallest range?
Stevens, Lane Rinky.
We have y is greater than equal to negative 3. What's the smallest?
And along with that, the 7th grade junior high football
If
players
y is
are doing
greater than
impact
equal to
testing.
negative 3, what is the
IAP,
smallest number?
if you can,
Negative
not
3.
after school.
Can it be negative 3?
Yeah.
Yep. So I put a square
You
bracket.
guys need to all report to
Negative
room
3.
208, which is Mr. Jurgens' room for the impact testing.
You say negative 8.
No.
There's so much
'Kay.
going on right now.
So then what is the biggest?
Infinity.
Infinity.
Or positive.
Positive infinity. Now, can I ever get to positive infinity?
No.
Nope. So what do I put at the end?
Brad.
Nope. Parenthesis.
That's what I meant.
Okay. So the top is set notation, and the bottom is interval notation. Now, just to let you know, guys, listen please. Your assignment is what? 10, 3 through 8? Page 10, 3 through 8?
Sounds too
Now listen. We got through a lot of the notes. If we can get through the rest of them tomorrow and you get started on your assignment, then we can take more time answering questions and things like that, right?